So the next part of the discussion here is industrial important organic compounds preparation. One is A, preparation of ethylene or ethene from ethyl alcohol. If you take ethyl alcohol, CH3 CH2 OH, when treated with concentrated H2SO4 at 170 degrees centigrade, it undergoes dehydration to give CH2 double bond CH2 plus H2O. Here concentrated H2SO4 is acting as a dehydrating agent, which we call it as removal of H2O, dehydrating agent, removal of H2O, because here from the ethyl alcohol we are removing one water and the obtained product, this is alcohol, this is ethanol or ethyl alcohol, and this is ethylene or ethene, dehydrating agents. Sometimes you can take even P2O5 also, phosphorus pentoxide also can act as dehydrating agent, that is removal of water. So here again, if you go for the second method, manufacture of ethyl alcohol through fermentation process. What do you mean by fermentation? Decomposing an organic compound in the absence of O2. Decomposition of organic compound in the absence of O2 at 30 degrees centigrade temperature with a fixed pH value. The pH value to obtain simpler organic compound is simply called as fermentation. So if you go for starch plus grain gives glucose. When you say grain, it is sprouts, and sprouts, when you say this is sprouts, and grain is malt. Starch is malt plus sprouts gives glucose. Glucose is a carbohydrate. Basically, starch is a polysaccharide. So this starch, if you take the molecular formula C6H10O5 taken n times, this upon hydrolysis, n number of hydrolysis gives n number of hydrolysis gives that is sucrose C12H22O11, n number of glucose molecules. Here I can take 2 molecules of polysaccharides. This is diastase enzyme. This is sucrose. This is starch. So take that sucrose C12H22O11 and again you subject it to hydrolysis in the presence of maltase. You get C6H12O6 plus C6H12O6. This is glucose plus fructose. Glucose and fructose have same molecular formula, but they differ in the functional group. The molecular formula is same, but they differ in the functional group. So their properties also they differ when you go for glucose and fructose. In the molecular formula format, they may be having the same molecular formula, but if you go to the structural representation of glucose and fructose, they differ in the functional groups. Because they differ in the functional group, they have different characteristic tests. So however, both glucose and fructose, they are functional isomers to each other. So take glucose from there, that is C6H12O6. When you subject it to decomposition, subject it to fermentation, when you are subjecting it to fermentation, this glucose decomposes to, that is C2H5OH, 2 moles of C2H5OH plus carbon dioxide, 2 moles of C2H5OH plus carbon dioxide. So here we have plus carbon dioxide is the byproduct, and here you got ethyl alcohol. This is a simple method of preparing ethyl alcohol. This ethyl alcohol, actually we call it as this ethyl alcohol, we also call it as ethyl alcohol. We also call it as absolute alcohol. Mild consumption of absolute alcohol, mild consumption gives drunkenness, and the same ethyl alcohol, this ethyl alcohol is mixed with the small amount of methanol and little amount of methyl butyl ketone, and it is this composition, it is used for unfit for drinking purpose. And we call this as methylated spirit. So if you go for this ethyl alcohol, the most important application is, that is consumption of this, is the important application of ethyl alcohol is breath analyzer by the Department of Police, that is called as drunken driving. To check the drunken driving by the police department, what they do is they use the oxidizing agent. That is the orange color crystals of potassium dichromate, which contains the dichromate ions in it. These dichromate ions, because they are acting as oxidizing agents, these dichromate ions, which is orange color, which is acting as an oxidizing agent, is treated with CH3CH2OH. It immediately gets oxidized to, that is minus H2O, add one nascent oxygen, it gets converted to acetaldehyde, acetaldehyde, and the acetaldehyde further, by adding one more nascent oxygen, it gets converted to, that is dichromation as an oxidizing agent. It gets converted to acetic acid. Once it gets converted to acetic acid, it becomes bluish green color, which is measured through the extent of length of tube. This bluish green color is observed through the extent of the length of the tube. Whatever the length of the tube, the bluish green color is observed in the length of the tube. With that length, we can expect how much amount of alcohol has been consumed by the traffic people, and with the help of that, the police department is going to analyze the gravity of the situation, and they try to take charge of the people who are trying to consume alcohol and driving the vehicles, and thus they prevent the accidents. Not only that, here, apart from that, nowadays the Department of Police is also using a fuel cell. This fuel cell is used to detect carbon hydrogen, carbon alcohol, and carbon to carbon of alcohol bonds using infrared spectroscopy. This infrared, when we are using infrared spectroscopy using the fuel cell, we get different peaks are analyzed on graph paper, which gives the complete picture of the amount of alcohol being consumed by the traffickers in the consumption of alcohol, and thus depending upon the graph which is obtained, we can check the amount of alcohol being consumed.